Hello and welcome. My name is Inge Patsch, and in this video we will learn how to read a causal loop diagram. And therefore we'll have a look into the different elements which are part of these causal loop diagrams. Let's start from the loop. A loop will look somewhat like this and has different elements in it. So the first one are the variables, A, B, C, D. So we have different variables in our example here, A, B, C. And then we have links between these variables, which should show the relationship between actors, activities, people, organizations, or whatever our variables are. And then you see that next to this link, there is a small plus. So plus can be, you can read it if you want to speak it out in the language. You would say the more of A, the more of B, or the more of B, the more of C. Or it could also be read the less of C, the less of A. So the main thing is the relationship is staying the same. You don't like switch the sign. It's either the more, or the less of X, the less of Y. And then last but not least, we can see that there is a loop. So this means it's circular, it's coming back. So A is going to B is going to C, and C is coming back to A eventually. And this is another element which all system loops, as the name is saying, have in common, that they are basically loops. And in the middle, you can see this small symbol of an avalanche, which as a reader helps you to understand, even without doing like the math and having a look into how is it a reinforcing or a balancing loop. You can see when you see this avalanche, or we'll learn about other symbols later, that this is a reinforcing loop. This means it's like incremental, it's reinforcing itself. It's getting the more, and therefore you have an exponential growth. So one example for such a reinforcing loop would be the more sales, the more satisfied customers, the more satisfied customers, the more positive word of mouth, the more positive word of mouth, the more sales, which would be a typical reinforcing loop. You can see that when it's a purely reinforcing loop, you see I have taken a very plain way of showing it. This doesn't have any symbol in the middle, nor does it have a plus. So sometimes if we have only positive relationships, only positive links, or only links which are like on the same page, it could also be shown like this. Another example, very common to the current time which we have, would be the more fear of a virus people have, the lower is the immune system. The lower the immune system is, the more people will get sick in an overall population. The more people are sick in an overall population, the more dramatic the media coverage will be. And the more dramatic the media coverage will be, the higher will be the fear of the virus. So you see how this is also a reinforcing loop here. I have chosen a different symbol for reinforcing in the middle with the R, and you see it can go round like this, or it can go round like that. Doesn't make any difference for the pattern. Another example of a reinforcing loop, which this time has two negative links in it. So we can see that the number of key variables considered to be externalities is negatively linked to the ability to see the feedback in system. And there is a second one, which is saying the extent of the system approach is negatively linked to rely on the market mechanism. So by having an even number of negative links, we still have a reinforcing loop, because it still will go up and up and up. So let's read it out loud, how it would go. The more we rely on market mechanisms, the more we will consider, the more key variables will be considered externalities. So the more factors which actually make a difference, we say, hey, it's outside, it's not part of our process, it's outside, it's an externality. But the more we make key variables our externality, the less we are able to actually see the feedback in the system. So the less we can see a dynamic going on. And the less we are able to see the feedback in the system, the less we'll recognize the need for a systems approach. And the less we'll recognize the need for a systems approach, the less we will make or implement the systems approach. But the less we implement the systems approach, the more we will rely on the market mechanism, and the more we rely on, and so on and so on. But I could also positively read in saying the less we rely on the market, the more key variables we consider the more key variables we consider be the less we rely on the market, the less key variables we consider to be externalities. So we include them in our thinking, in our modeling. And therefore, the higher is our ability to see the feedback in the system. Therefore, we recognize more and more how a systems approach can be helpful. Therefore, we apply system approaches more and more, and therefore we less rely on the market mechanism and so on. So this can also be a loop the other way around. Yes, a small exercise. Maybe you can try now to make your own loop. So look at these three variables: the demand for energy, the burning of fossil fuels, and the economic development, and try to make your own reinforcing loop. Maybe you pause the video here, and when you have drawn it on a piece of paper, you can continue. All right, here comes the solution. So it would be the more demand for energy there is, and you can start reading a systems diagram anywhere you want. I can start from demand for energy, I can start from burning of fossil fuels, or wherever it fits you for remuneration best. So the more demand for energy there is, the more burning of fossil fuels there will be. The more burning of fossil fuels there is, the more economic development there will be, and the more economic development there is, the higher the demand for energy will be. All right, that much about reinforcing loops. I guess that should be fine. Let's look now into balancing loops. Balancing loops are in comparison, so above we see again a reinforcing loop, so we can see we have like 4 positive links, and in a balancing loop, one link is a negative one. So we would have a negative link between the variables of B to C. And we can see as a symbol, very often some kind of scale-like symbol is used here, but sometimes it's also a circle with a B written in it. One example would be the higher the quality of a product is, the higher is the customer satisfaction. The higher the customer satisfaction is, the more demand for this product will be. But the more demand for this product will probably result in a lower quality, as your infrastructure might be overwhelmed. So we see how this is making a balance here. Another thing we can see in this, this diagram is that I have changed the plus and the minus to an S and an O, because plus and minus always has like a value of good or bad, and S and O would be an option to also write the same thing. So S simply means same, so the correlation is like the more or the less, versus O would mean opposite, so it's saying the more the less, or the less the more. So the more demand, the less quality, or the less demand, the more quality. Yeah, so a reinforcing loop can also be connected with a balancing loop, as in this very simple example, saying you have the variable of the population, and then population is influenced by 2 variables. One is birth and one is death. So you can say the higher the population, overall population is, the more births will be, because there will be more females, or more couples producing children. And then the more births there will be, of course, the population of whichever species will grow. But then also we can say the higher population, the higher the total number of population, the higher the total number of deaths will be, and the higher the total number of deaths, the lower the population will be. So we can see how here are 2 loops operating to keep the population basically at bay. Another example of a combination of a reinforcing loop and a balancing loop would be the reinforcing loop saying the higher the temperature, the lower the ice area, the lower the ice area, the less reflection of radiation back to space. The less reflection of radiation, the more radiation will be absorbed, and the more radiation will be absorbed, the higher the temperature. And then there is the balancing loop, which would say the higher the temperature, the more climate mitigation acts we might do, and the more climate mitigation acts we do, the less the temperature. So that much for balancing loops. I hope that they are also understandable, and let us now come to goal setting loops. So goal setting loops is where an actor or a system, mainly it's an individual actor, but it could theoretically also be an unspoken expectation of a system, like a company has a desired state of something. And then there is a current state, and there is apparently a gap between the two. So if the desired state and the current state, they don't match with each other, a person or a group is getting into action, and through this action, the current state will be changed and the gap will be reduced. So we can see that this is basically a balancing loop. So normally goal setting loops always have something to do with balancing and bringing back the situation of the desired state. So one example, a very simple example, is saying you have a cup of tea and you have a desired amount for how much tea you would like to have. So at the moment it's rather empty. So I want to have it up to a certain level. So my mind is calculating the gap between the current level and the estimated level. The action is to pull the tea in the cup. My eyes are following what is the actual level, and the lower the gap is getting, I will stop eventually my action and my cup will be filled. Yeah, that much on the gaps. And then there is another small thing I want to introduce to you because it goes well together and very often it comes together. These are delays. So we see another goal setting loop here, where in this case we have a desired temperature of a water. So imagine you're in a shower and they have this fossé, which is really having a very long time. So you turn it into warm, but it takes a lot of time before it's really warm. I'm sure all of you have been standing in a shower like this, no? So you have your desired temperature, how you would like to shower, and then there is a temperature gap. It's still too cold, no? So you will change the fossé setting, but there is actually a delay. How long time does it take until the current temperature will change? So you see that this delay is symbolized here by these two dashes. And therefore it will take a bit of time until the current water temperature changes. So we can have delays in goal setting loops, but we could have delays also in other loops. We will see later how, or in another video, how this actually affects then the behavior over time and the pattern which we can observe on the surface. I hope this short introduction into the elements of causal loop diagram has been helpful for you, and I hope you will be back for my other videos. Meanwhile, please subscribe and thanks for watching.